So here's a little video on partial fraction decomposition method. So we're going to run through a couple of these. This is from the worksheet that I handed out in class a few days ago. So we'll do numbers, let's see, we're going to do numbers 5, 7, and 9. Okay, so once again, when you see a fraction like this, you notice this is not a U substitution because that's top is definitely not the derivative of the bottom. It's not going to work well with well, if it's not U substitution, we're probably going to use partial fraction unless it is clearly a trig substitution, but there's no square roots or x squared is minus 1s and stuff like that. So this looks like a partial fraction. The bottom's already factored for us. So we're going to rewrite this as, oops, x over x minus 1 times x squared plus x plus 1. We're going to break that into two fractions where we say a is over x minus 1 plus b over x squared plus x plus 1. And then we need to find out what a and b is. So we do that, multiply both sides of the equation by the common denominator, which is x minus 1 times x squared plus x plus 1. Of course, if we do that, the whole bottom wipes out here, and I'm left with an x. Here I'm left with a times, oh wait, back up a second, sorry. Because this is x squared, we can't just put a b there. We have to consider the top we have to make room for the top to be 1 degree smaller than the bottom. So here, since the degree is 1, it's okay to have just a number there. Here we need the option to have a bx plus c. That way, if b is 0, then we just have a number. But if b is a number, then we actually have a linear term on top. So this is going to be a times x squared plus x plus 1 plus, and that's just going to be bx plus c times x minus 1. Now we got to get all the x's together, all the x squareds together, etc. So I'm going to multiply this stuff out. So, and I'm going to write over here, this is 0x squared plus 1x plus 0, just so we know what each of the things are, each of the terms are. And over here I'm going to have ax squared plus ax plus a plus bx squared, because of this times this, minus bx, because of this times this, plus cx, because of this times this, minus c, because of that. So then we know that, well, let's get all these together first. So that would be ax squared plus bx squared. Sorry. bx squared. And plus ax minus bx plus cx. And then plus a minus c. I think I got everything. So now, because 0x squared, if we'll do a little highlighting here, so this has to match with this. And that has to match with that. And finally, the 0 has to match with all of that. Oops, I missed one there, didn't I? That. So the purples match, the greens match, and the blues match. So which tells me I can set up some equations here. That means that 0 has to be equal to a plus b because of the green. And 1 has to be equal to a minus b plus c because of the purple. And 0 has to be equal to a minus c because of the blue. So I'll start down here. If a minus c equals 0, that means that c is equal to a. Very interesting. So, and also, up here we know that negative a is equal to b. So then we can take this thing and substitute in for, we're going to have 1 equals a We'll replace b with negative a, so that would be negative negative a. And we'll replace c with a, so that would be plus c. Plus a. So then we find out that 1 is equal to, looks like 3a, which means 1/3 is equal to a. Which also means that 1/3 is equal to c, which also means negative 1/3 is equal to b. So now we're going to rewrite our equation up here. It'll shrink it down a little bit so I can see it. There we go. So our integral now is going to be 1/3 over x minus 1. I'll put a dx in there because I can separate them. And the other one is going to be negative 1/3 x plus 1/3 over x squared plus x plus 1 dx. And then you would integrate from there. And in the interest of time, I'm going to just set up the integrals. So we're going to go to number 7. Yeah, number 7. Again, we want to factor these. Oh, now number 7 is unique because the top is greater than the bottom. The degree is greater than the bottom. So remember when the top is, this is kind of like a top-heavy fraction. So the first thing I have to do is divide. So I'm going to take 3x squared minus 6x minus 9 and divide that into x cubed minus 9x. X cubed minus 9x. Okay, so generally when we're doing this, we want to put in a plus 0x squared minus 9x. That way we can keep track of the missing terms. So we're going to say what times 3x squared equals 3x, and we're going to put the answer over here. So that would be 3x, because 3x times 3x squared, no, sorry, it's just x is what I meant to say. 1/3 x is what I meant to say. Because 1/3 x times 3x squared would be x cubed. 1/3 x times 6 would be negative 2x squared. And 1/3 times 9, 1/3 x times 9 would be negative 3x. And then we're going to subtract that, and we get 0, and that would give me a positive 2x squared. And negative 9 plus 3x would be minus 6x. So then we can do it again. And this time I ask what times 3x squared equals 2x squared, and that would be 2/3. So 2/3 times 3x squared would be 2x squared. 2/3 times negative 6 would be negative 4x. And 2/3 times 9 would be negative 6. So then we're going to subtract this again, and we get 0. Negative 6 plus 4 would be negative 2x. And negative 6 would be plus 6. Okay, so that means my answer is 1/3 x plus 2/3 plus a negative 2x plus 6 over 3x squared minus 6x minus 9. Okay. So then we would just integrate this thing. So if we integrate it, so essentially this thing over here is going to be the integral of 1/3 x plus 2/3, 1/3 x plus 2/3 dx. We'll just separate that out, plus the integral of negative 2x plus 6 over 3x squared minus 6x minus 9. 3x squared minus 6x minus 9. Okay? Now, of course, this will have to, so that we can just do, the first integral we can do, it's just a simple power rule. This one, we're probably going to have to use partial fractions, so we'll want to break that into, we'll want to factor that, so that'd be a negative 2x plus 6 over, if I factor that, that would be 3 times x squared minus 2 minus 3, so that'd be x minus minus 3 plus 1, and let's go ahead and put a 3 back in there. Actually what we could do is take a 3 outside, so let's rewrite this as, we'll put a 1/3 out here, and we'll have x squared minus 2x minus 3. Then we're really just dealing with that. Okay, so of course that will be equal to a over x minus 3 and b over x plus 1. If we multiply everything by the common denominator, we get negative 2x plus 6 is equal to a times x plus 1 plus b times x minus 3. And we get negative 2x plus 6 is equal to ax plus bx and plus a minus 3b. So now we know that negative 2 is supposed to be equal to a plus b. Oh, let's actually go over here. Negative 2 is equal to a plus b because of that and that. And 6 is equal to a minus 3b. So we got a system of equations here we got to solve. So you could multiply the top equation by 3. So that would give me negative 6 is equal to 3a plus 3b. Add those two equations together and you get 0 is equal to, 4a plus, so that means that a is equal to 0. Why is that? Oh yeah, because we can factor out a 2 there. Oh, yeah. Wish I would have noticed that at the beginning. So this is interesting. This is kind of interesting to show up here on the in using partial fraction decomposition, because what you notice here, if a equals 0, that means one of these things wouldn't have to be. And so why could that possibly be? Let's erase this and make some room to examine this. Why did that happen? Because I could take my original fraction, just like I factored out 3, I could also factor out a, say, negative 2. So then my integral would be a negative 2/3 out front, and that would leave me with an x minus 3 on top. And notice I have an x minus 3 times x plus 1 on the bottom, don't I? So of course that would cause the x minus 3's to cancel out. So then I'd end up with a negative 2/3 times the integral of 1 over x plus 1. Isn't that slick? Dx, of course. So then this piece right here would turn into, well, it was a minus, wasn't it? Minus, wait, was it a minus? No, it was plus, okay. Plus, oops, plus the integral of, oh, it is minus because of the negative 2/3. Okay, so that's what I was thinking of minus. Okay, so it'd be a minus 2/3 integral of 1 over x plus 1 dx. And again, that'd be an easy d over u type integral, which would be natural log. So then you just would integrate this right here. Of course, this is not done. I'm being clear on that. I'm just showing you a partial fraction decomposition part and then leaving this for you to integrate. Okay, and then the last one is number 9. This is another one where I want to factor or divide the bottom and the top because the top is because it's the top of your fraction. I think we did one like this in class. Maybe we didn't. Yeah, I think we did that one in class. So I think I'll do this one here instead. Number 8 is the integral of, and on this one I'm going to factor out a 2 just so I can see it better. That'd be 2 times x squared plus 5x plus 6. And on the bottom, x squared plus 3x plus 2 dx. So I can take that 2 outside and not let it bother me. And then we could factor the top and the bottom just to make sure we don't do something like we did last time and make a problem harder than it is. So this would be 2 times 3 plus and plus. And on the bottom, I would have what? X and 2 and 1 and plus and plus. And sure enough, the x plus 2's can cancel out, can't they? So those will cancel out, and that'll leave me with a 2 times integral of x plus 1 over x plus 3 over x plus 1 dx. And that's not a partial fraction anymore, is it? So this one's maybe a little bit challenging. This is a good use of substitution problem. Let me run through that real quick. So I would probably pick u to be x plus 1, and then that would make du equal to dx, which is nice. But then I'd also solve for x here and find out that u minus 1 is equal to x. So then I could rewrite this as 2 times the square root of, and in place of x, I'm going to put u minus 1 plus 3 on top. And on the bottom, I'll have just a u, and then a du out here. So notice, if we'll highlight real quickly, just so you can make sure you're following this, the u minus 1 took the place of x. Everyone see that? And the u, of course, took the place of the u plus 1. And the 3, of course, is still just the 3. That didn't change. And last but not least, the du and the dx match up exactly because they're right there, aren't they? Okay, so then we can go ahead. It's a good reminder of u substitution. So then we can go ahead and simplify this a little bit. 2 on the outside, the integral of u plus 2 over u du. Of course, I can simplify that to 2 times the integral of 1 plus 2u to the negative 1 du. Now we're ready to integrate. That's going to be 2 times u plus 2 times 2, that'd be 4. And the integral of that would be ln u plus c. But of course, what was u? U was u plus x plus 1, so this would be equal to 2 times x plus 1 plus 4 ln of x plus 1 plus c. And there we have it.